An LLM is a brilliant guesser. Most of the time, that's exactly what you want, right up until the moment that you need the same answer every time. But every run is a fresh guess. And a few months back, I was running negotiation simulations, dozens of them. And each run put the agent through a particular scenario. Between runs, I had to reset the board, archive the last run, copy in a fresh set of source files, and delete the one file that did not belong in the next scenario. Get the files right and the run is clean. Get one file wrong and the whole scenario is contaminated. But you don't really find that out until the results don't make any sense. So for a while, I manually handled the reset. Then I had the agent handle the reset. I described the next scenario and asked it to actually move the files for me. And most of the time it worked, but it would decide to like read the source file and then write it out into the new folder instead of copying. It was a massive waste of tokens. And some of the times it actually copied the wrong source file or left the file that should have been deleted, and I would burn an entire run before I realized what happened. Then it hit me that, I was asking a guessing machine to do a job with exactly one correct outcome. Moving files is not a judgment call, it's a script. So I stopped describing the reset and just wrote it. Small PowerShell script that archives the last run, copies the right source files, delete the one that doesn't match the next scenario's parameters. This worked the same way every time. The agent still ran the negotiation, the ambiguous part, the part that it's good at. The reset part, that has one right answer, and that was moved to code. The fix was not a better prompt. It was to stop asking the model to guess at all. The large language model guesses by design, and that is a feature. It predicts the next token, and that's the whole engine. When you ask it to write a function, name a variable, or draft an email, then prediction is a superpower. There's no single correct variable name. There's no one true email copy. You want range. You want the model to explore. Ambiguity is the point. But prediction is a terrible way to move exact files between runs, or worse, rewrite them. It's a terrible way to look up a customer record. It's a terrible way to decide whether an order can ship or not. Those tasks have one right answer, and the model has no idea whether it landed on it. It just knows that, it looks plausible. So you get a strange split. The same tool that makes AI feel like magic on creative work makes it feel like a liability on anything that has to be exact. Most teams respond by babysitting. They read every output. They add, "please be accurate," to the prompt. They cross their fingers, but none of that actually changes the engine. The engine still guesses. It still predicts. So picture your model's work as an ocean. Most of it's open water, and open water's fine. You want the model swimming there. But some tasks are not water, they're rock. They have to hold weight. These are islands of certainty. These are places in your workflow where answers must be the same every single time with no exceptions. The mistake is asking the ocean to be an island. This brings me to determinism on demand. The entire premise is that you hand the model a tool, not a task. The move is simple. When the task has to be exact, you do not describe it to the model and hope. Instead, you give the model a deterministic program that it can call, and you let it call that program the moment it needs a sure thing. The whole idea comes down to one rule. The LLM decides when. The code decides how. Think about what that splits apart. Deciding when the negotiation is over is a judgment call. It depends on where the conversation actually is. That is exactly the kind of ambiguous read the room work the model is great at. But resetting the scenario itself is not a judgment call, it's a function. It takes inputs and returns one correct output the same way, every time. And that belongs in code that you wrote and tested, you can point a finger at. The model stays in charge of intent, your code takes over for the execution. That switch is the deterministic handoff. It is the exact second the model stops improvising and calls something that cannot improvise. And once you see that split, you cannot unsee it. Half of the AI reliability problems that I hear about are really just tasks living on the wrong side of the handoff. Somebody asked the ocean to hold weight. Most teams keep their AI knowledge in prompts. A prompt is a note that you hand the model. When you reset the scenario, copy these files and delete that one file. And that works sometimes, but not every time. The model reads your note, nods, and then does its own thing anyway, because a note is a suggestion to a guessing machine. The upgrade is to stop writing the note and start building the capability. Take the reset logic out of the prompt and put it in a real script. Then register that script as a tool the model can call by name. Now the model does not read about how to reset the board. It calls the reset tool, and the files land exactly where they belong, and it moves to the next run. The good news is that you can get the model to help you actually create that script. Anthropic published agent skills as an open standard, and DevNitro supports these skills. And the skills come in two flavors. Some are pure guidance, prompts that shape how the model thinks, while others are script-based skills. These are skills that include real runnable code that the model calls when it needs a sure thing. DevNitro actually allows adding a small definition file along with that script, and then scripts actually become first-class tools sitting right next to the other built-in capabilities. But either way, the model sees it, and it picks the moment when it fits, and it calls it with validated inputs. And if it fails, it tells you why it failed instead of sitting there struggling. The best part is when both flavors work together. In that simulation I created, a prompt skill kicked it off each negotiation, and it set the tone. Then a script skill cleaned up after the run, and it prepped the next run. Guidance where the work was ambiguous, determinism where the work had one right answer. That's the difference between a suggestion and a capability. A prompt lives in one developer's head, but then evaporates when the tab closes. A promoted skill is reviewed, versioned, and callable. Your organization owns it. Every session inherits it. The real question is not whether your developers have AI, it's whether your organization has it. A prompt library is not organizational AI. It's a pile of sticky notes. A library of deterministic callable skills is organizational AI because the capability lives in the system, not in whoever typed the best prompt that day. So, when do you promote a task to a skill? You don't promote everything. That would be its own mistake, and it would kill the range that makes the model actually useful. The test I use has 3 questions. Does it need the same answer every time? If the task is a calculation, a lookup, or a rule with one correct output, the model should not be guessing it. You promote it. Next question is, does it have to be auditable? If someone might ask, why did it do that? You need code that you can read and a log that you can trust. A model's reasoning is not an audit trail, so you promote it. The last question is, does it touch a real system? If the task queries a database, hits an API, moves files, moves money, or changes state, you want deterministic execution with validated inputs and a clear failure. Never let the model freehand that. Instead, promote it. So if a task trips any one of those wires, it's an island, not open water. Build the skill. If it trips none of them, leave it in the water and let the model do what the model does best. I've spent 29 years building software, and a decade of that was as a Microsoft MVP, watching patterns repeat across teams. This is the same lesson the industry keeps relearning. You do not make an unreliable component reliable by asking it nicely. You put a reliable component where reliability is required, and you let the flexible component do the flexible part. Here's the takeaway that you can use today. Stop trying to prompt your way to certainty. You cannot argue a guessing machine into never guessing. You can only decide which parts of the work are allowed to be guesses and which parts are not, and then hand the do not guess parts to the code. The LLM decides when, the code decides how. Find one task in your workflow that has to be exact, that gets babysat today because nobody trusts the model to get it right, and promote it to a skill. Pull the logic out of the prompt, wrap it in a function, make it a skill the model calls, and then you can watch the babysitting disappear. That is determinism on demand. Not a better guess, a sure thing the moment that you need one. I'm Chad Carter, helping developers ship production-ready software faster. You already know what you're doing, so now go and ship it. And hey, if this helped, you know the drill. Plus, you may want to go ahead and share this with a developer that you like. And I'll see you in the next video.